All right, there you go. Done. Let's bring up the monitor. I'm going to hold down the rotary encoder with my finger to make sure that its connections are solid and turn it to see what's going on. All right, so you can see as I'm turning it on one side, one direction, okay, numbers are increasing, counts are increasing. Other direction, kind of, nah, it's a very noisy signal, so I can't really see what's going on here. Right, so there's a lot of noise in this channel. And I'm going to bring in my oscilloscope leads, and I'm going to plug the yellow one to the one that I will use as trigger. So that's CLK. I'm going to plug CLK here. I also need to ground the oscilloscope lead. So I'm going to use another extension, another jumper wire, and plug it into the ground rail. And for the second channel of the oscilloscope, I'll use the orange lead, and again I'll ground that here. Okay, now on the oscilloscope side, I'm going to do a single capture. And as I turn the knob, you can actually see that there's a quite clear signal. Interesting. So the signal that I just produced is quite clear. So the yellow is the CLK and the blue is DT. Let's try this one more time. So as I turn the knob now clockwise. Okay, so as I turn the knob clockwise, you can see that the DT, just double check. So blue goes to orange. So orange is DT, orange goes to blue. So the blue signal here is DT and is the one that is grounded first. So that goes first. Then you've got clock, which goes down later. So you've got a signal here, which is 0, 1. And also you can see there's a bit of noise here and a bit of noise here. If I zoom in the blue channel and increase the time, here you can probably see it. There's a bit of noise here that could confuse the Arduino in its readings. I'll do a couple more measurements to see what it looked like, just to average out. So yeah, you can see a bit of the bouncing noise here and here that went all the way down. Do one more. Okay, so this is clockwise. You can see there's one, right? And one more clockwise, right? Go. Blue first, yellow second. We didn't pick the blue change in state, so the still doing clockwise, but the yellow this time went first. So there's a lot of issues here. So when you've got the blue first and then the yellow drop, the Arduino detects a clockwise movement. But when you've got the opposite, let's see if I can generate one more. So blue first, nope. If we have yellow first, I did it earlier, but let's see if I can do it again. Nope. Oh, you have something like this, or this is a really bad signal. Something like this, or this, yeah. Anyway, it's inconclusive. The signal is not very clear. So that's why the Arduino is getting a bit confused about which way the knob is really turning. Right, so if I press it, I go to reset. Before we see how we can improve the situation, let's have a look at the sketch. This is the unbounced version of the sketch. So I set up the pins first. So pin CLK goes to 2, DT goes to 3, and the button goes to 8. This is how I keep track of the virtual position of the knob, and I'm declaring this long variable as static because I'll be referencing it from inside the interrupt service request routine. I'm going to come back to this interrupt service request